Right now, 3D printing is a little bit more of an art than it is a science. It incentivizes innovation. It incentivizes rapid growth in the system.
Are there any industries that you think outside of like defense where it could be useful down the line?
Any industry with critical supply chains, construction, mining, medical parts, the long-term goal is to make this ubiquitous, is to make the barrier of entry so low. That has been the big problem that we have been working on over the last couple of years. Now we can do that, but with the entire defense industrial base supporting it.
Eric, coffee, tea, or something else? What fuels your mornings?
Can I say all the above and in copious amounts?
Okay, you need to explain that one to me.
Oh man,
Now.
it's and is it limited to mornings, or can we also say afternoons and some late nights sometimes? It's
That is fine.
whatever's within reach at any given moment. But it is typically lots of coffee and occasional some tea. My mother, who's British, would be proud of me.
Oh yeah. Oh, there we go. Love that. Okay, cool. I know all about the tea consumption myself, as you can tell from the accent. When you were a kid, what did you think you'd grow up to be?
I didn't exactly know. For a time, I was very interested in House MD, and wanted to be a doctor and kind of exploratory in that sense. But I should have known, or at least the folks around me should have known, that I would eventually be an engineer by how often I would break stuff in the name of fixing it. So I guess it was always destined to me. I just didn't know it until I was a little bit older.
That's awesome. Was anyone else an engineer in your family or that you were around?
Not exactly. My father did work in kind of computer science to a certain extent, but more as a kind of network and server manager at UC Berkeley. And my mom was a nurse, so I guess to a certain extent, the mentality was there, but maybe not the title.
Interesting. Okay, very cool. What's one technology that you can't live without?
I'm going to be so generic here, but it's going to be my phone. It's how I interact and reach out to all the people that we work with in my team and coordination. But if I had to come up with a second one, it'd probably be my car, because that's the other way that we communicate and reach out and get places. So it's I think that is probably ones that everybody can empathize with.
Yeah, can definitely relate to in this day and age. If you can fast forward 10 years and see one impact that your work's had on the world, what would you want that to be?
That is a complicated question, and it's one that I've been thinking about. But if I had to choose one thing, I would hope that the technology that we develop saves lives. At the end of the day, whether that be through direct action, whether the technologies that we build or that we're building right now have a direct impact that helps save lives and keep groups like our warfighters safe, that would be the biggest impact I can hope to have. But on a whole nother level of creating technologies that help strengthen the US and our allies, to enable us to be able to be successful in all future endeavors, and to protect we hold dear to us, as a country, as a country and her allies, and as a people. And that is what helps me get up in the morning, is to create technologies that help support not just us as an entity, but the vision that we have as a people, and to be able to protect that and enable those that protect that.
Awesome. Powerful. Welcome to Machine Minds, everyone. I'm your host, Greg Terusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Eric Shnell, founder and CEO of Crater. Thanks for being on the show today, Eric.
Thanks for having me, Greg.
Yeah, my pleasure. I know we have rescheduled this a million times, not that.
Took
And
us
it
a little
almost
while
happened
to get
again.
it set up here.
Yeah, I know, but I'm glad this is a good time. This is a good time. So let's jump into it. Um, let's start with you telling us about your path before founding Crater. What led you into advanced manufacturing and into focusing on defense and defense tech?
Well, I started in the 3D printing space pretty early. I got into it in the rep days back early 2010s, kind of when it was hobbyist, forum based. People were making things out of cardboard and MDF and different like wood frames and coming together and just starting to figure out where 3D printing would go before I grew to where it is now. And in that space, I was mostly doing it because I wanted to make drones, little quadcopters and stuff. Drones before the current interpretation of drones, mostly just little racers and things like that. But I ended up getting a lot more sucked into the whole 3D printing space and doing a lot of work there, kind of in the hobbyist community. That eventually evolved when I went to college and went to UC San Diego as I became a peer mentor and a supervisor for one of the maker studios on campus, which would eventually lead me to meeting a recently retired Marine that was very familiar with the Marine Corps' efforts to try and implement 3D printing at the edge or in the field. That led me to meeting with that group and becoming a strategic technical advisor to the Marine Corps in 3D printing. So I spent about 6 months kind of hopping with different units and working with groups that were trying to implement 3D printing, whether it be supporting reverse engineering, part identification, training development, procedure development, or working on modifying commercial off-the-shelf platforms to be able to 3D print in the field, which is where the idea of Crater came from. We started working with these groups and kind of the more traditional 3D printing OEMs, and saw that there was a great promise to where 3D printing could go for the warfighter, but there was a lot of work to be done, and all the different groups we reached out to were not willing to do that work for the space. In fact, I was told on not one occasion or more than one occasion that it was not a big enough market for them to really care. And that made it a little bit personal, not just because I'd been working alongside these Marines for over 6 months at that point, but just by how important their job is. I don't get me wrong. I understand that business, first and foremost, needs to make money and needs to survive here. But there is an importance behind the capability that I figured couldn't go without. So we formed Crater around the vision of developing decentralized expeditionary manufacturing, originally primarily focused on hardware, but that has grown so much more over the last few years.
Awesome. Yeah, I really want to dive into all of that and hear more about the areas that you're covering, because I was curious about the initial problem that you guys are trying to solve, which you shared. But whenever you unearth one thing and your customers start telling you new stuff, it always like brings new product sides, new offerings, new things like that. So where are you guys at right now?
It's quite a leap, I will tell you that. We spent many years actually working in this space. Crater was founded in 2019, and we spent a majority of the last few years directly collaborating with the Marine Corps, the Army, and the Navy through what's called a CRADA, or Cooperative Research and Development Agreement. We were very lucky on that collaboration to actually be fully embedded within the Marine Corps and enabled to work alongside them every single day. So at the very beginning of COVID, when we started this effort, it just happened to work out that we were able to get a 20-foot expandable shelter in the middle of Camp Pendleton, where we worked every single day alongside Marines, testing, iterating, breaking, seeing what worked, what didn't. My desk was right next to another desk of a Marine that we worked with all the time, and they provided that live feedback to the capabilities, we often joke that in the afternoon, we'd go out into the field, we'd test it, we'd break it. That night, we would make revisions to the engineering design. We'd throw those new parts on the 3D printer overnight. In the morning, we'd install it. In the afternoon, we'd do it all over again, seeing what worked and what didn't. And the benefit of COVID in this case, a little bit of a blessing in disguise, was that while I was still in school at UCSD at the time, and most of my team was, we had all of our classes remote. So we were taking our lectures on mobile hotspots out of the office there while we were working on this effort here. And we did that for about 3 years, developing, iterating, breaking, until we eventually got to what we have launched just as of this year, FieldFab, which is our flagship product. It's a 3D printer that is mill standard 810H. Basically just means that it's ultra rugged, ultra hardened. You see a lot of phone cases claim to be mill standard 810. So same standard, except a lot more testing and qualification. What that means practically is that this printer can print critical parts, high grade parts in the field from a -40 to 120 degree environment. It can even print underneath tactical transportation. So ground transport, sea transport, and even more recently, air transport.
While it's in motion, it can be printing?
It
Wow.
can, yeah, which means not needing to stop. One of the benefits of 3D printing is quick turnaround. So when it comes to large scale efforts of logistics and production, parts can take days, weeks, months. We've seen years to get where they're needed. And unfortunately, that's not a unique problem. That's most parts across the DoD and generally these restricted supply chains. So while we're able to print them same day, it takes a few hours typically to print parts. So it is actually very critical, especially in an expeditionary environment, to be able to move around. Sometimes it's only 5 minutes, but if you were to stop that print halfway through the print cycle to move 5 minutes to a new location, then now you got to restart on any other 3D printer. In this case, we're able to do continuous transportation printing, stop and go printing, all of that, and be able to continuously manufacture. The vision behind FieldFab is to be a vending machine. It's be something that's so boring, so ubiquitous. It's like the printer machine down the hallway. You don't get advanced training on that. You just get a little 5-minute introduction by the guy who's spot you're taking and now know how to use that hardware. And that's the vision that we've had with FieldFab and been able to succeed with, as we've recently been able to demonstrate training operators that have never seen a 3D printer before in under 15 minutes to be able to print certified OEM-based parts.
That is amazing. Wow. And I'm sure like moving the needle drastically for the people in the field that need this. And I don't know if there's any use cases you can share with us or success stories that I'd love to hear about. But before we get there, question about Camp Pendleton. And what was it like for you working there when they're doing like munition testing and stuff? I've always been curious about the volume and the because I'm in South Orange County, so I'm not even there, but it is loud. We hear it here. So when they have those schedules on, what's that like when you're actually at the camp?
I will say I've gotten a little used to it over the last couple of years because we're going to school out of UC San Diego. We have jet fighters flying over us almost every single day. And right now I live just north of Miramar. So I've gotten a little bit adapted to it. I'm used to the whole pausing for about 30 seconds on a call until the jets go over. But on base, it's even louder. So a lot of the times it's kind of it's almost like a background noise that isn't too disruptive because it's an active training base. But there is an occasion where we would have let's say something a little bit noisier. We were just over the hill from the MCAS or the Marine Corps Air Station there, in which they mostly fly helicopters out of and fly in a different direction. But occasionally they'll have F-35s or something fly in, and because it's primarily a rotowing airstrip, those F-35s are coming in VTOL or vertical landing, and so we've had a couple times where those guys come in 100 feet above our shelter there, and I didn't think the jets could get louder, but they definitely
Really?
can. You can't even hear
That's
yourself
so
think at that
crazy.
point. But
Y-
it
Yeah,
it
I bet.
was the best possible environment to make this capability. It really required 1,000 different dialing in tunings, levers on the engineering design to be able to perform how it can and make sure it's designed specifically not only for the field, but for this specific type of operator. And that's essentially how we got there. And we did it by an entirely passive mechanism. So the end design of the system, a lot of people think that it is actively dampening for the vibrations and the shocks. But one of the big considerations we had is limited space, limited power. So we wanted to do it entirely passively. And we were able to do that just by really fine tuning the engineering behind the mechanical frame and our electronics in the system.
Amazing. And I guess from a speed standpoint, just to get to that point of clarity and testing and iteration, you need time, obviously with COVID and everything like that, but being in this setup where you can test it in the field and come back and edit it and then or amend it and then throw it back out there again for testing so quickly must have saved you guys like years of development time from a traditional standpoint. Yeah.
And it oftentimes surprises a lot of the people that we are now releasing the product to, and just how much consideration has gone into how it's going to be used and how the different units interact with it. And it's because that the reduced barrier there, the constant communication and the ability to just test and iterate in its own right based off the advantages of 3D printing in the field led to us making a lot of quick, small design decisions that allowed for the system to be as successful as it is. And all the way from just how the door opens to how we connect it to power to what different types of power it connects to. There's the mill standards that establish kind of best practices, but there's a whole other part of this that's just based off of guys on the ground saying, hey, this sucks, this works, it'd be better if you could do this, but multiply that by hundreds or thousands of different operators and dozens of different field deployment environments all going into making this platform. So while we were the vehicle to making field fab, really it is based off of an entire collaboration of thousands of individuals, most of them warfighters, that have provided feedback to making that happen. And we were just the instrument that made it.
That's awesome. What were the earliest prototypes like?
They were more like a printer in a box. A lot of people ask me if field fab is really kind of just a printer in a box. And if you take it to the most basic principles, sure, it's in a box and it's a printer. But there is so much between that, which was day one. Day one, we started work with a printer with one of our great partners, Matter Hackers, who we still work with closely today. They provided us a system. We put it in a box with our partner, SKB, who provided us a system back then. We were bootstrapping all this in the beginning because the collaboration came with in-kind services, but not funding for a lot of the development. So I was paying for this on a college level income, which, as I'm sure you can appreciate, was negative. So we relied and worked heavily with partners to be able to do that first version. And it was a printer strapped into a box with a lot of its electronics removed and hardened. But from there, that's essentially what we developed and evolved from. And right now, the system is so much more than that. The entire frame has been designed around transmitting vibrations through it without affecting print quality. The overall insulation and double walls allow for us to go down at -40 and print without it being in a tent. We can throw it on the back of a Humvee going through a -40-degree environment and be able to continuously print with just basic AC power provided to it. And all of that is just based off of that polishing, that feedback that we got from the Marines, the soldiers, the sailors that we were able to work with.
It's so crazy to even hear, and I need to see this I can't get my head around how it works like that in motion, and that's pretty wild. Well, what type of parts or use cases are most common for your customers today?
They can be pretty generic if you think about it. The DoD is its own supply chain, and it's just way more restrictive. Unfortunately, you can't Amazon 2-day ship most of the parts that they deal with. But it's stuff anywhere from transportation, things for their vehicles, things for communication gear. You can think of brackets, you can think of cable supporting, cable harnessing, strain relief, connectors of different types that are all kind of one-offs or very limited procurements. Getting into the medical space, there's tons of medical parts that are already being generated and more so right now that are being built up, and various different components. A lot of people ask or assume weapon systems must be pretty common amongst those. Surprisingly enough, the U.S. Department of Defense has more than enough weapons. So it's actually very little that we're touching anything like that. And it's mostly kind of just the general logistical support, what they call Class 9 items, which are consumable or semi-consumable parts, gaskets, grommets, pieces like that wear out and need to be replaced. And they're also sometimes the hardest things to replace on the platform. More recently, though, and I'm sure this comes as a surprise to no one, has been quadcopters, drones, UAVs, UASs, robotic systems. That's almost been 75% to 90% of the parts we've been printing recently. And that's mostly because we've partnered with a lot of groups that are driving these into the field. Because 3D printing, a lot of these innovative new solutions, not only provides a vehicle to be able to do these at scale where they're needed, but also provides an opportunity for us to take that innovation cycle that we were so lucky to have with the DoD of kind of day by day being able to innovate in less than a 24-hour period. And now we can do that, but with the entire defense industrial base supporting it, because we can connect engineers in Ohio who are building out a capability and iterating based off of what is being seen in the field, and they can immediately digitally translate that to a warfighter in the field who can then print that, use it, test it, provide feedback, and iterate on an hourly basis as opposed to weeks, months, years, which is kind of what we're limited to now, which gets a little bit into the broader ecosystem that we've built beyond Field Fab.
Yeah. I'd love to learn more about that if you can share, because I'm curious what else you're doing. I mean, not that this isn't enough, and it sounds super impactful, and like I hadn't even thought about all of these other areas, that consumables and things that break in the field. And one question before you jump onto more of like the ecosystem, what, from a user standpoint, like if you have troops in somewhere remote, what do they need to operate this or to get a part? Do they need like the CAD of this part on hand? Are they able to spool something up quickly in the field? Like if it's something super custom, what materials do they need to bring with them to, apart from like obviously the printer and the power source, like what else do they need to use it?
Well, you're getting into the question behind why we built an ecosystem. Because at the end of the day, at the end of the day, the printer is a printer, and the printer is a means to an end. And the warfighter doesn't need a printer. The warfighter needs parts. So whatever gets them those parts is what is required to build, to essentially enable this ecosystem, which has been one of the big issues for adoption over the last couple of years. Right now, 3D printing is a little bit more of an art than it is a science. And what I mean by that is that it's highly dependent on the skill of the operator to be successful in manufacturing those parts. And to a certain extent, that's even the case with Field Fab. When it comes to an individual part-by-part basis, there's a lot of dialing in that needs to happen, optimization with different materials. And the approach that has been done up until this point is taking warfighters, putting them through a 1 to 2 week course, graduating them as pseudo-engineers so they can design those part files themselves in the field. And while we still enable that, we actually have a tablet that integrates into the front end that we can run stuff like SolidWorks or Fusion 360 CAD programs that they're trained on and familiar with, so they can do that design in the field if need be. the greater problem that we've been working to solve over the last couple years has been, how do we take the massive defense industrial base within the US, this great amount of training and talent and knowledge of our engineering base, and put those brains where it's needed most, in the field alongside our warfighters, where those parts can be generated ahead of time or at the time of need. And that has been the big problem that we have been working on over the last couple of years. And I'm excited to announce that as of the last week, we demonstrated the beginning of our first platform to be able to do that. And that is the Greater Marketplace, which is a vehicle to connect OEMs, original equipment manufacturers, the innovation within the US defense industrial base, directly with warfighters. It is a platform that we have built that leverages a technology that we call secure TDP, or secure technical data package, which is a file type based around a PDF. It looks like a PDF, it talks like a PDF. You look at it, you think it's just a 2D drawing of a part. But what's unique about it is that we actually embed and encrypt detailed profile information into that and the 3D file. And I can do offline controlled distribution from endpoint to endpoint in a way that operates not too unlike Signal, the messaging app. We can do zero trust mechanisms for enabling the distribution of part files, and I can do it through various different mechanisms. Right now, we're centralizing it on this marketplace because we can granularize the IP exchange. It's like DRM, but specifically for 3D printers. And I can allow an OEM to package and certify how to print something and take that data, and they can share it to the endpoint, and endpoint being FieldFab. FieldFab can take that data, it can upload the profile, it can upload all the details on the materials, and it can upload the 3D file, it can orient it, it can place it, I can set it up exactly how that OEM intended. And all that warfighter has to know is, how do I download that part? How do I upload it into the software, the slicer here, and then press print. And the system will automatically calibrate itself. It will set it exactly how the OEM intended it to be. It will print it, and then that part file will self-destruct. So all the data that is tied to actually printing that part is gone off the platform after the usages, or after the prescribed amount of usages, which allows the OEM to have control over who's printing their part, how many times they're printing their part, how long they can print their part for. All of these things go into enabling that OEM to have a level of control that allows them to take that risk of sharing part data on a digital level. And we're using this to build a digital marketplace so that OEM can granularize their IP and sell it at a part-by-part basis, which allows the warfighter to be able to buy it by a part-by-part basis. At a unit level, they can be able to purchase just that part that they need, and they don't have to rely on the program office or big Army, big Navy, big Marine Corps to negotiate ownership of those licenses. The benefit of this mechanism as well is that it incentivizes innovation. It incentivizes rapid growth in the systems. Because right now, if you certify and approve a part and then put it into production, then there's so much momentum behind keeping that part exactly the way it is, not iterating, not changing, which requires more engineering up front to get it to a point where you can do that. This lowers that barrier for innovation to reach that end unit and allows for iteration to happen at the speed of minutes as opposed to years. And that is one of the big pieces that we've been trying to take, is the experience that we had as a company when we were just starting out in this really unique space, and allow it to be done at a scale that takes advantage of the entire defense industrial base and the entire Department of Defense.
So cool. That is so cool. I didn't know that you were going to announce any of this today. We spoke about other stuff offline, but this is great. So thank you for sharing. I'm super happy that you have, and it's really eye-opening, and also gives you a lot to think about, because everyone thinks when you have a defense company, and there's obviously defense is a very hot space right now within the US within robotics and manufacturing. But all of these consumables, all these other parts that the troops need, that your warfighters need, that you can't just carry unlimited supply with you, that this is such an amazing fix and make it's like a no-brainer, right? So the fact that it works, the fact that you've got this ecosystem coming and that you've got all this innovation enablement is it's great. Like it's so good to hear. Are there any industries that you think outside of like defense that or any other applications that you see that might adopt the technology or where it could be useful down the line?
Right now, any industry with critical supply chains. And that's mostly just due to the cost to play. This level of 3D printer is a little bit more expensive than most of the other ones that use Hume. It's entirely made in US, it's AS9100D, and it's mill standard A10H. Those come with some extra cost burdens on being able to produce the system. And so right now, the cost to be able to do all this is mostly limited to critical supply chain industries. We talk about energy, transportation. Recently, we've been working with groups that do a lot of construction, mining, various levels of support. We've been working together with a handful of OEMs that operate in that space. We'll be able to take advantage of and support them in those spaces. But the long-term goal is to make this ubiquitous, is to make the barrier of entry so low that you can imagine this at any number of different locations, in which it's just shortening that distance from the person who needs a part and the person who has a part, or at least has the digital part. So long-term, I see this as kind of going back to our original comparison of the machine, a vending machine. Ubiquitous, easy to access. But we're starting initially with the most critical supply chain, the Department of Defense, which is a little bit actually of an easier space to operate in. It's harder in some ways, and a lot of companies that are dual use actually start in the commercial space or industrial and move into the defense space. We've gone the other way because the unique ecosystem here is that there's kind of controlled inputs and outputs. I know both sides. I know the DoD and I know the OEMs. I know the defense industrial base. And so we're just creating the bridge between an existing network. But when we start expanding into other commercial industrial spaces, it starts to become a lot more fluid. And so those spaces are a next step. And then we start looking into longer term, into more of a commercial space. That's the most fluid space of them all. So we're kind of going structure to less structure over time as it becomes easier to field this system at a cheaper price that is more adoptable by more groups.
Love that. Yeah, you can see a huge need, again, no-brainer one for things like energy, oil and gas with super remote locations, high usage of parts, but then also like cost as well. Like if you're on an oil rig and you need a part, it's a great solve.
There's a lot of revenue lost. We've heard it quoted that an oil rig being down for a 24-hour period is multi-millions of lost revenue. And so the system pays for itself in less than an hour.
There you go. Again, no brainer. Let's shift gears for a second, because I know you and your team and, when you guys were all at UC San Diego, I want to talk more about team and culture. What kind of talent have you built around you at Creator so far? Like what was the founding team looking like, and what do you look like now?
Yeah, the original founding team was a group thrown together out of UC San Diego that I started working with initially when we were still kind of in this advisory stage. The original founders were, one of them I worked with out of the Maker Studio on campus. He was another supervisor. One of them who is currently kind of my core co-founder, Akil. We met rummaging through a recycled PCB bin, essentially within that Maker Studio, and I still remember the joke that he and I said to each other was, "That guy looks like he knows what he's looking for. We need an electrical engineer. Let's talk to him." And he was a freshman at the time, but he definitely proved that he knew what he was looking for, and has been kind of my direct counterpart all through building both Crater, the team, and the product. So I'm the mechanical engineer behind everything. He's the electrical and software engineer behind everything. And we together are the primary creators of Field Fab. So we did almost all of that ourselves, but we grew a team around us to be able to support that and support other efforts. Most of our team, or a good amount of our team, are veterans who've done their time and served their country, and have now come on to help us better be able to translate our capabilities into supporting the warfighter, not just based off of the experience we had hands-on, but their knowledge, their backgrounds in the different spaces they operated in. So a good amount of our team wore the uniform before, but not just that, because this is a collaboration behind academia, behind industry, behind our warfighters. And so we've been able to grow this team around a shared purpose, that the capability we are building is not just the future of being able to do logistics and supply, but future logistics supply is the future of national defense. And it has been a big part behind joining our team together under shared vision. And just about everybody who started with us is still with us to this day. And it's not been a short amount of time that we've been building this capability and only recently getting into market. So I've got a great team. I love every one of them. And we're just now starting to get to a point where I assume this time next year will be a lot bigger.
Well, if all the things we've spoken about offline are coming together, I can only imagine what it's going to look like in a year. So that's awesome. For a startup in such a mission critical space, what qualities do you actually look for in team members, or now when you're going to start scaling, what are you going to be looking for in new hires?
It's the same for both, but a little bit of differences. So prior, or I guess the core value that we look for is shared vision, because this is not an easy problem. And it's a big ecosystem that we're getting into with a lot of moving parts. It's a very complicated ecosystem. Sometimes I spend hours on a call to just explain all the different moving pieces and all the reasons why we do what we do to new people coming into the space. And there needs to be a level of acceptance of that everybody on the team is lateral to each other. They all have to know why we do what we do and why we're building what we're building, both on an engineering side and also just generally on a marketing and development side. And so vision is a big part of it, in aligning those visions in that culture, and being flexible to working in various different environments. As much as we try and support everybody still having a work-life balance, startups are hard, and startups are oftentimes soak up a lot of our time, a lot of our effort, and when starting out, for very little reward. But it is about the vision and getting together and being willing to do that together to be able to reach that, and being able to communicate well amongst the team is another key part, because just because everybody shares the same vision, things change, and we have to move with the punches, and we have to be able to grow together. And so communication, vision are huge parts to what I look for within a team that is a team of peers. I mentioned lateral, and I mean that in multiple senses, but every single person on my team is critical to being able to execute the vision that we're building, which requires us to operate as peers, as collaborators, as friends, and being willing to do that extra mile because you know that the person beside you has got your back. And I will say it has been a blessing and a privilege for every single one of my team that I work alongside now, and especially for those who have worn the uniform before and who have served, who know what that means and can help bring that into our culture and be able to allow us to grow in a way that we are focused on the customer 100% of the time at all times. And the customer here is our partner in that sense. Going into the future, as we grow our team, that will remain the same baseline requirements for anyone on our team. But the benefit to us is that we start to be able to bring on people that maybe don't have quite as much flexibility when it comes to compensation and stuff like that. That starts to get a little bit into the nitty gritty and the weeds. Anyone who's been in startups knows that nobody gets paid what they're worth until a certain point. And the benefit now is that we can start to be more flexible, and people that we've wanted to work with for years, that we have great relationships with, that we already know will be excellent additions to our team, but who have essentially been kind of on standby doing their own thing until we're at a point where we can actually support their life needs so that they can, be able to do this and also have work-life balance and also have families and be able to support everything else they do. That's what's really exciting me over the coming months, is that I've got a number of people that I can't wait to work with on a day-to-day basis, and I can't wait to be able to support them in their livelihoods so that they can help us build this vision.
That's such a aware and mature perspective as a founder and as a leader. And I just want to highlight that, because I work with a lot of, I work with a lot of startup founders, and there's always, I talk about one of the best and most important traits that a founder can have, in my opinion, and it's the self-awareness of themselves, but also of the business, right? And then, so things in that are like, when you know that you're a bottleneck, or when you need to hire another expert to delegate stuff to. So that's about the self-awareness, but then business awareness of your positioning in the wider industry and who you want to attract from a talent standpoint. Like, we speak to people every week that are like, I just want to hire people from SpaceX, Tesla, and video. Well, no one knows who you are. You can't pay them. There's no real value add here. Like, let's be real. Or the flip side is, we want to hire someone with 15, 20 years of experience. They need to take $100,000 and we want them to work 7 days a week. I'm like, not going to happen, right? Because someone at that stage in their career is likely a family person, has other things going on, and excuse me, my throat, has other things going on, but also has a lifestyle that they need to maintain, right? Whether they're the breadwinner or they have kids in school or whatever it is. So the fact that you are aware and intentional and communicate that stuff, and that, hey, I've earmarked people and we're going to bring them in when the time's right, and they know that, because we have to check these boxes, can only add in a positive way to your culture, to your hiring process, and to your engagement from a staff level. And I think a lot of founders need to have that perspective when they're building their teams, instead of being like blind to reality, which sometimes you have to talk people in. Hey, great that you want that. I understand why, but if you want that, maybe look at a grad who doesn't mind working 14-hour days or 7 days a week for little money, because they have a lot to prove. Like, someone who's already done that in their career, it's a harder sell unless they're going to be a co-founder, right? So
I do ask a lot from them. Our team, I ask the world, and I get it from our team. But I do believe that the reason I can get that is because we as a team view each of our individuals as part of that team, and the team doesn't exist without every single one of them. And there is a unique culture that is built around, especially having a team that is either so heavily tied to the Department of Defense, or even has warfighters. Warfighters have already given their all to their service, and have, by the time they're retired, and everyone that we work with is retired, they've already had that expectation thrust on them, and they've already committed to doing that. And a lot of times they come into this space kind of thinking that they need to do that too. But that's already been asked of them. And that is, to me, unfair for me to ask of them as well is to put your life on pause to be able to do this. I know there's plenty of successful companies and startups and groups and founders and entrepreneurs that do have that perspective. But for me, I like to work with people I like to work with, and I like them to like to work with me too, and like to work on the vision that we're working on. And so it is important to me to make sure that each and every one of them is taken care of, so that if they can give their all, they do give their all. And it is my job as essentially the enabler, as the leader here, to put them in a position to be able to give their all. But that doesn't mean giving their all every single day, taking time away from the family and making commitments that puts the rest of their life on hold. And I would never expect that of them. And I think that it ends up developing a culture that it's just people who like to work with each other. And I will say that I am truly glad to say that I think we have a team. Maybe I shouldn't speak for all of them, but have a team that likes to do what we do, believes in the vision, and believes that we are going to have the impact that we want to have for our customers and for our partners.
Love that. I'm conscious of time, so just a couple of questions before we wrap, because I know you are a very busy man, especially at the moment. In general, what excites you most about the future of robotics and manufacturing convergence and just in-field or field-ready manufacturing?
What excites me is just how much we don't know what tomorrow is going to hold. Because the space that I'm in is I'm trying to reduce that barrier for innovation to grow. And it has an exponential impact. The more we cut away the chaff, the more way that we enable innovation to iterate quickly and in the space and in these environments, the more that we'll get exquisite designs and incredible engineering at a just more accessible basis. And this is beyond just in the defense space. This is all over the place. If you can imagine how it would look 5, 10, 15 years down the road, when you can essentially have innovation at your fingertips, not even getting into leveraging AI and various different capabilities that are only growing by the day here, then we start to realize just how impossible it is to foresee the future of these technologies and the innovation, because they will grow exponentially. And the only thing that we can be certain of is that if we guess how tomorrow is going to look, we will be wrong. We may have some insights, but and that's just the speed that everything's moving. And I'm excited to work in the space that helps enable that to be able to happen faster, because then someday I'll want to be part of that as well.
Yeah, for sure. Is there any advice that you would give to aspiring founders in defense tech or advanced manufacturing?
I would say go out there and do it. It's so, I'm sorry, it's very cliche. It's probably been said 1,000 times. But it really is the truth of any of these spaces. What I used to say when I was still out of UCSD and I was asked that same question was that students go do it. You're like, there's no reason you need to wait to get the training that you need to go do something. I wasn't a mechanical engineer, technically, a degreed mechanical engineer for 4 years as I was still working on building Crater. Field Fab itself was built by technically an undergraduate mechanical engineer at the time. I've since graduated, but that just goes to show you is that postponing building is not in your best interest, but also not in the best interest to the people that you may one day serve and be able to enable. And so I would say that anyone's ideas are worth putting to paper, building a capability, and the barriers to getting those ideas into reality are going away one by one. just generally with 3D printing, if you imagine just desktop level systems, they were thousands of dollars when I first started into 3D printing. And that's why I went into the hobby market to make them myself. But now you can get these for a couple $100s off of Amazon and be able to create your ideas and build on them. And it doesn't need to be perfect the first time. You can try it out, see that it sucks, then try again. As I mentioned, it took us years and hundreds, if not thousands of iterations to get where we are now. And the benefit of that barrier being non-existent or so low is that just starting your idea is the hardest part. Then it just becomes iteration and adoption and knowledge. And as you start to build something, others who share your vision will surround you. There's many people that I work with now that I just met through being out there, throwing myself out there, sharing our vision. None of the people on my team were essentially hires that I went to go find. They were people that I met, knew, networked with, who came around our vision, was interested in it, and committed to it. And that would have never have happened if I hadn't just decided to back then, fuck it, I'll do it myself. I apologize. I don't know if that's if you need to bleep that or not, but
I think you are right that advice has been given, but it hasn't really been given in that context of even at college, like even at school when you're there, just do it. And for so many reasons, I agree, because of everything you said and people you serve and just the time it's going to take you to get to where you're going. But also, even if what you are doing doesn't amount to anything, like it doesn't become a commercially viable company or product, the experience you gain, super valuable. And from a hiring standpoint, because that's obviously where I spend my time, when companies are looking at grads to hire, or if they're going to come out and go to a startup like Crater, you're going to look back at internships on teams that you've been part of extracurricular stuff. And if you said, I've been working on this startup and this is the product we have, and you have stuff to show, it separates you from everyone else. It's a differentiator, valuable experience, and there's no price you can put on that. So yeah, huge encouragement for people to do that.
I will say, if I get a resume with a portfolio on the back, I throw the resume aside and I look at the portfolio. And it's because you know who a person is by the things that they create. And creation begets creation. The more you do it, the more you learn, the more you'll have ideas, and the more you'll know what works and what doesn't. Resumes are good for seeing what you know, but engineering especially is all about how you apply what you know. And I don't really understand somebody until I see them build something.
Love that. I think that's a great place to stop. Thank you so much for being on the show. I really appreciate it. I'm so glad that we actually got to do this finally. Where can everyone find out more about you and Crater and follow along or apply to jobs and see what you guys have going on?
Absolutely. So we can be found at crater.com, which is our primary website. We're on LinkedIn. We don't have a lot of the other socials all set up yet, but we will in time. And follow along there. If you want to ever reach out or are interested in kind of what we're doing on a more direct level, you can reach us at contact@crater.com.
Awesome. Thank you so much again, Eric. This has been great. And I will speak to you soon.
Thanks so much, Greg. Thanks for your time here. And I look forward to talking again here soon.
Pleasure.